Hello everyone, welcome to lecture series on computer organization and architecture as a part of third semester subject. This video is a part of learning management and system under the Department of Collegiate and Technical Education. This video corresponds to Module 5 Basic Processing Unit. The main objectives of this module are how a processor executes instructions, the internal functional units of a processor, how they are all interconnected, how processor will going to generate the control signals. In that, two methods we are going to consider. One is hardware approach, another is microprogramming approach, and last part includes microprogram organization. In this subject, in the first four modules, we are studied about the parts of the computer, how all those will going to work, like how input unit will going to work, output unit, memory, how memory is organized, how it is made up of. Everything we are studied in the previous module. In this module, mainly we are going to concentrate on the processor. That is the main part of the computer. First, let us go through fundamental concepts. As we know that we have to execute any of the program means we have to perform any of the particular task means first we are going to write a program. Program is nothing but sequence of the instruction. Everything we are going to store in a memory. But we have to execute that program means everything should be first brought into processor. So to execute a program, the processor fetches the one instruction at a time and performs the operation specified in an instruction. Whatever the instructions we are having in a program, everything is stored in the memory in the successive memory location, nothing but consecutive memory location, one after the other. Processor, it will going to fetches the instruction one by one from the consecutive memory locations until whatever the instruction fetcher, that will be one of the branch or the sub instruction. So the address of the instruction which has to be fetched from the memory location, that will be available in one of the register, that will be called as the program counter. So processor, it will keep track of the address of the memory location from which next instruction has to be fetched using one of the register, that will be called as the program counter. After fetching one instruction, the content of PC will going to update to the next address of the memory location. If branch instruction appears means program counter content will going to differs with the another value. It won't be next memory location address. So in processor, we are going to consider one more important register, that is called as the instruction register. So this instruction register, it will going to hold the current instruction which has to be executed. Nothing but from the memory we have fetched one of the instruction. That instruction will going to be available in the instruction register. That will represent that instruction has to be executed currently. So IR, it will going to hold the current instruction to be executed. That is memory of the memory from which it is specified by the PC. So let us assume that each instruction comprises the 4 bytes. Nothing but whatever the instruction we are written, if we convert that into equivalent machine language, here we are going to assume that each instruction comprises the 4 bytes, and we are going to assume that in each memory word it is able to store the 4 bytes of the data. Nothing but here we are assuming that whatever the instruction is there, that will going to fit in the single memory location. So to execute any of the instruction, the following steps we are going to consider. First step is fetch the content of the memory location pointed by the PC. As I already told that PC will going to hold the address of the instruction which has to be fetched from the memory location. So based on the PC content, go for fetching the content of the memory location. Then these content are interpreted as the instruction to be executed. So we have to load that instruction into the register called as the instruction register. So first step will be load the fetched content into the IR. That one will be represented like this. So from where we are fetching, that will be taken as the source. Source will be represented in the RHS side, and from there where we are going to load. So that one we are going to represent in the LHS side. So here PC content will be loaded into the instruction register. As we already assumed that memory is byte addressable and each instruction comprises with 4 bytes, and each memory location is able to store the one particular instruction. So first instruction we are fetched from the memory location means PC content should point to the address of the next memory location. So we have to increment PC by 4. So here you can observe PC register content will going to updated with the new content that will be equal to initial value of PC added with 4. Nothing but PC plus 4 will be updated to the content of the PC. So PC will be updated with the new value. That will represent that PC is pointing to the address of the next memory location which has to be fetched. Next instruction which has to be fetched. So once particular instruction is fetched and loaded into the higher, then carry out the action specified in the instruction. Nothing but if we have fetched one of the instruction like add R0, R1. In that add will going to represent the what type of the operation it has to perform. Nothing but add corresponds to it has to perform the addition operation. If instruction occupies more than one word, then whatever the steps we have specified in 1 and 2 must be repeated until complete instruction is fetched. So nothing but whatever the instruction, single instruction is there, if it will occupies more than one memory location, during that time we have to repeat the steps 1 and 2. Then only it is possible to fetch the complete instruction, then only we can perform the particular operation. First 2 steps, whatever we are represented, that steps will be called as the fetch phase, and step 3 constitutes the execution phase. So we have to perform any of the particular instruction execution means 2 phases will be considered. One is fetch phase and another is execution phase. In fetch phase, we are going to fetch the instruction which is stored in the memory location, and in execution phase, processor will going to execute the particular operation specified in an instruction. Now let me go through internal organization of the processor. In module 1 only we have studied what are all the internal parts of the processor. In that we have specified like MAR, MDR, general purpose register, instruction register, program counter. So like that we have represented in the block diagram, but in that we have not shown any of the connection. So here we are going to consider how all those are interconnected. All will be organized in several ways, but here we are going to consider the simple organization. Mainly it will consist of arithmetic and logic unit along with the several register. This is the figure which will going to represent how all the units within the processor are interconnected. You can observe here all the units are connected through one of the bus. This is the bus. This bus is called as the internal processor bus. This bus is different from whatever the external buses we are considered, like memory bus, address bus, data bus. All those buses are different. This bus is only corresponds to the processor to move the data from one unit to another unit within the processor only. It won't interconnect with the other parts of the computer. For that, we are going to use the memory bus. Here you can observe this is memory bus. It will going to connect this overall processor with the memory of the computer. Here you can observe mainly it consists of PC, that is program counter. Program counter is nothing but it will going to holds the address of the instruction which has to be fetched from the memory. Second, MAR, that is memory address register. So whatever the data or instruction we are loaded in the memory, we have to fetch from the memory means first the address of that one we are going to store in the MAR. From the MAR it will be connected to the memory through the memory bus. Those address will going to carry out from some set of lines. Those will be called as the address lines. So once again, whatever the content stored in the memory, either it may be an instruction or data. Once we fetch from the memory, that has to come to the processor means that will come through some set of lines that will be called as the data lines. Those content we are going to store in one of the register called as the MDR, that is memory data register. Along with that we are having a general purpose register. Here we have specified R0 to Rn-1. These are the general purpose register. All these register we are going to use explicitly in an instruction also, like move R0, R1. That will represent we have to transfer the data from the register R0 to R1. So R0, R1, R2, all these register we are going to specify in an instruction also. But some of the registers are there. Those will going to behave like a temporary register and we are going to use our processor that will going to use internally. That one we won't go for using in any of the instruction. So some of the temporary register here we have mentioned is Y, Z and also tab. These are the temporary register. These registers are not used in any of the instruction explicitly. Next, one of the important block in the processor is ALU. ALU corresponds to arithmetic logic unit. It will going to perform so many arithmetic and logic unit. So depends on the control signals generated by the processor. So processor, it will going to generate the control signal that will be fed as input to the ALU. So here you can observe add, sub, XOR. So depending on which control signal will going to activate, ALU will going to perform the operation. So to perform operation, it needs data. So that data will going to come through the lines, that is A and B. So whatever the input we have to feed to perform arithmetic logic operation, that one will be forwarded to the ALU through the terminals A and B. Here you can observe terminal B is directly connected to the bus and terminal A is connected to the bus through one of the temporary register Y and also the mux. Along with that, we are having one more register called as the instruction register. As I have already told, instruction register is one which will going to hold the instruction which has to be executed. Once we fetch the instruction from the memory, that will be loaded into the MDR. From the MDR, it will be forwarded to the instruction register. From the instruction register, it will be forwarded to the instruction decoder and control logic. It will going to decode the instruction. Based on that, it will going to generate the control signal. If fetched instruction is add or not comma R1, something like that, then decoder will going to generate the control signal add. During that time, it will going to activate the add signal which is corresponds to ALU. Then ALU will come to know that it has to perform the addition operation. Based on that, based on the input fed from the terminal A and B, it will perform the operation and result will be forwarded to the destination through the register Z. You can observe the output of the ALU is connected to the register Z. So like this, all the blocks or all the units of the processor are interconnected through the single bus. That bus is called as the internal processor bus. So this overall organization will be called as the single bus organization of the processor. So let me consider how it will going to operate. So one of the instruction we have stored in the memory means first the address of that will be available in the program counter. Program counter passes that address to the internal processor. From the internal processor, it will be loaded into the MAR. From the MAR, it will be sent to the memory through the memory bus. And simultaneously, read signal will be activated. During that time, memory will come to know that processor wants the data. In that particular memory location, whatever the data will be there, that will be fetched and it will be sent to the MDR register through the data lines. MDR will going to holds the data. If that is the instruction means it will comes to the instruction register. From the instruction register, it will be sent to the decoder. Decoder, it will decode that instruction. Based on that, it will generate the control signal. So like this, operation or fetching of a particular instruction will going to take place within this particular processor. So same thing I have represented here. So here Data and address lines of the external memory bus, whatever shown in figure, are connected to the internal processor bus via memory data register and memory address register. MDR mainly consists of two inputs and two outputs. Nothing but either we can send the data from processor to memory or from memory to the processor. So that is bidirectional. Therefore, memory data register consists of two inputs and also two outputs. Data stored in MDR may be placed on either bus. But in MER, the input is connected to the internal bus and its output is connected to the external bus. MER is always unidirectional only. Always processor will going to issues the address to the memory. So processor will send the address to the memory through the register MER. So there will be only one particular direction for the MER register. The control lines of the memory bus are connected to the instruction decoder and also the control logic block. This unit is responsible for issuing the control signals. Whatever the instruction that will comes to the decoder, it will going to decode. Based on that, control logic block will going to generate the control signals. And as I have already told, there are n number of general purpose registers are there. They will be designated as R0, R1 like that until Rn-1. There are some of the registers which are dedicated for special purpose like index register, stack pointer. Afterwards we will go through that one. There are some temporary register we are going to consider like Y, Z and temp. They are transparent to the programmer and never used in the instruction explicitly. We won't go for using those instruction in those register in the instruction. These registers are used by the processor within the processor only to store the data temporarily. Along with that, as we observed in the diagram, ALU consists of two inputs. I have represented two terminals. I have told A and B. Input B directly comes from the internal bus, but terminal A is connected to the output of the multiplexer. For the mux, you have observed that for the mux, there are two particular input. One is select Y and another is connected to the bus. So select Y, we are going to use to feed the data directly to the terminal A. Another mux input is one of the constant value, that is 4. That is mainly used to increment the content of the PC. As we know that once particular instruction is fetched from the memory, content of PC will going to updated by the new value. That will be always equal to PC plus 4. To perform that, one of the fixed input terminal to the mux will be equal to constant 4. To perform the increment of PC, constant 4 will be selected in the mux. Otherwise, the terminal Y will be always selected to perform some other operations. The decoder will going to generate the control signal based on the instruction whatever it will going to receive from the instruction register. The register, ALU and interconnecting bus are collectively referred as the data path. Whatever all those units we are connected, everything will be called as the data path. So Here we are going to consider if processor wants to perform any of the particular operation, means what are all the different operation it can perform. Based on that, here mainly we are consider four different operations. One is transfer a word of data from one processor register to another or to the ALU. This is corresponds to operations which will going to takes place within the processor. Within the processor, we are having in general purpose register. If you want to move the data from one register to the another register, nothing but both the registers are available within the processor only. So transfer of data from one register to another register or from one register to the arithmetic logic unit, which is also available in the processor. That is one type of operation. It can take place within the processor. Second thing is perform an arithmetic or logic operation and store the result in a processor register. Some arithmetic or logic operation will be performed using the ALU and result has to be stored in the processor register itself. That is the second operation we can consider, which will going to take place within the processor itself. So these are related to the registers and ALU which are available within the processor only. But sometimes it is necessary to fetch the data from outside the processor. Nothing but from the memory we have to fetch the data. And we have to transfer the data from processor to memory. So those also we are considered for the operation like fetch the content of memory location and load them into the processor register. So this is nothing but transfer of data from memory to the processor. Last operation is store a word of data from processor register to a given memory location. Nothing but from the processor register, data will be moved to the memory location. So from this session, whatever we are studied from this, we are able to answer following questions. Explain the general steps needed to execute the instruction, and with neat diagram explain the internal organization of the processor using single bus. For the second question, we have to draw the diagram and we have to explain how operation will going to take place. Multiple choice questions. Based on whatever we have studied, we can answer following multiple choice question. First question is dash register holds the address of the next instruction which has to be fetched from the memory location. That is one of the register called as the program counter, PC. Second question is MDR has dash number of inputs and dash number of the output. It consists of 2 number of the inputs and 2 number of the outputs. As it is bidirectional, data can be moved from memory to the processor and from processor to the memory. Third question is there exists a separate block consisting of various units to decode an instruction. Yes, it is true. It consists of one of the unit called as a decoder. Fourth question is which of the following is register is not accessible to program? That is one of the instruction register. Programmer can't make use of the instruction register. Fifth question is in memory read, memory address is loaded into a dash register. That is always memory address register which will going to holds always address of the memory location. Either that memory location corresponds to data or instruction. Sixth question, dash holds the content of accessed memory location. Once we fetch the data from the memory, the content will be loaded into the MDR register only. So these are the references book. Myself, Baby HT, Associate Professor, Department of ECE, GC, Assam. Thank you.